Hi everyone, welcome back to Chem Help ASAP. In today's video, we are going to talk about a very common way that atoms bond to form molecules, and that is through an ionic bond. Now from the name, you can probably guess that it involves ions, so make sure you're comfortable with your cations and your anions. If you need a refresher, please check out my video on that. But if you've ever wondered about the composition of the salt on your table, keep watching because I hope to answer your questions. Let's start by just defining what an ionic bond is. An ionic bond is a bond that is formed by exchanging electrons. Now this bond is formed between a metal and a nonmetal, and ionic bond, it has ions, so it's formed between a cation with a positive charge and an anion with a negative charge. And then those two ions are electrostatically attracted to each other. And we will start actually with table salt. So if I were to look at sodium and draw the Lewis structure for sodium, it has one valence electron. Come across the periodic table, take a look at chlorine. It has 7 valence electrons. Now, remember your octet rule. Sodium would like to dump that extra electron, so it has the electron configuration of neon. Chlorine is desperate to gain an electron to then get the electron configuration for argon. So I call this the match made in heaven. Sodium wants to give an electron, chlorine would love to get an electron, and we have an ionic bond. So we end up with sodium, the cation, with a +1 charge. Chlorine, the anion, with 8 valence electrons and a negative charge. And this is how table salt is formed. Now, any compound formed by an ionic bond with an exchange of electrons is called a salt. So let's form another salt. Let's take a look at magnesium and oxygen. So we have magnesium, 2 valence electrons. Oxygen, 6 valence electrons. You can probably already see where I'm going with this. Magnesium would love to dump these 2 electrons because then it would have a full outer shell. Oxygen would love to gain 2 electrons because then it would have a full outer shell. So we have an exchange. Magnesium happily gives oxygen those other 2 electrons, and now we have an ionic bond. Magnesium becomes the cation with a +2 charge. Oxygen becomes the anion. It has taken those 2 electrons. It now has 8. And it has a -2 charge. This is another salt. This is magnesium oxide. But what happens if the electrons that one atom wants to lose and the other wants to gain don't match up? So what if we were to look at calcium and fluorine? So calcium has 2 valence electrons, fluorine has 7. Calcium wants to dump both of these electrons. Fluorine wants to gain only 1. Now, calcium is not going to give just 1 away and form a bond. It's either going to get rid of both of those electrons or it's simply going to stay neutral. So how can we deal with that extra electron? Well, what we do is we bring in another fluorine atom that wants an electron. So we have 1 electron will go to 1 fluorine atom, and this electron will go to the other fluorine atom. Now calcium has lost its 2 electrons, and both fluorines have gained an electron. So calcium becomes the cation. It has a 2+ charge, and we have 2 fluorine anions, each with a -1 charge. So here is one fluorine atom, and here is the other fluorine atom. Now, this is drawing it through Lewis structures. If you were to draw the molecular structure, you would simply write CaF2. So let's predict what happens when aluminum and bromine bond. So aluminum has 3 valence electrons. Bromine, just like fluorine, has 7. Again, we have to work out a deal where aluminum can lose all 3 of its electrons. So instead of just having 1 bromine atom or 2 bromine atoms, of course we are going to bring in 3 bromine atoms. They each have 7 valence electrons. So aluminum simply gives an electron to each of these bromine atoms. And we end up with aluminum as the cation with a 3+ charge and 3 bromine atoms, each with a -1 charge. Again, if we were to write the molecular formula, this would simply be AlBr3. So by understanding valence electrons and being able to predict the charges that elements will have, we can then predict what kind of compound will form when we bring 2 different elements together. Now you've probably noticed that I have very clearly stuck within the s orbitals and the p orbitals because the transition metals and the f orbital metals can have multiple charges. So ruthenium, for example, can form 2 different ions. It can form a 3+ cation or a 4+ cation. It still forms ionic bonds, however, because it is forming an ion and it will bond with an anion. So if I were to bring chlorine in, and we know that chlorine wants a charge of -1, then I could form either ruthenium 3 chloride or ruthenium 4 chloride, again depending on how many electrons ruthenium gives away. If you have watched my video on naming ionic compounds, now maybe you understand a little bit better why for transition metals, when we name these compounds, we have to give the oxidation state of those metals. Now when someone asks you to please pass the salt, you'll say, which one? Just like chemists do all the time. Although I do recommend just sticking to the sodium chloride if you want to season your food. Anyway, ionic bonds are not the only ways that atoms come together to form molecules. In our next video, we are going to talk about covalent bonding. So I hope you will join me for that. And thanks so much for watching.